What is up, guys? Jordan here with ObjectiveC Tutorials lesson 34. We'll be talking about polymorphism. Now, it's been a long time since I did one of these, but I'm super excited to get back into doing these and to finish out the series and continue teaching you guys how to code. So without further ado, let's get into it. Now, quick refresher, last lesson in lesson 33, you talked about inheritance, and inheritance is just like what inheritance is in real life. You inherit traits from your parents. They're passed down to you. So we talked about how you can put common functionality in a superclass, and then you can have different subclasses which inherit from that superclass. They take the common functionality, but then they can have their own specific functionality. So we haven't coded anything yet because we first need to talk about polymorphism. So what is it? Well, it literally means taking many forms. And there is the actual dictionary definition from Webster-Merriam Dictionary, the quality or state of existing in or assuming different forms. So it's a very biological science term. And that's basically what it means in programming as well. It means the ability of different types of objects to respond to the same message, each in their own way. So right here, we have two objects. You see the NSString object, which is red. So that is just a string. I believe we've used that. If we haven't, it would just be like hello. That would be a string. And then a UI image, user interface image. That's what the UI stands for. So you have a picture and a string of letters. Now we send the message detail to both of these objects, and each one of them, as you can see, represented by the different shapes, they each do something different when they receive this message. This is really what polymorphism is. So you send detail to the string, you get a yellow diamond. You send detail to the image and you get, I believe, purple hexagon. So yeah, that's what polymorphism is in a nutshell. Now, I've learned about polymorphism from multiple different sources, and each one seems to kind of take its own take on it, especially when you learn about it with regards to Objective-C and then with regards to a programming language like Java. So I'm going to tell you all the different explanations and kind of how I learned it, because I learned it a little bit in Objective-C, then I learned it in Java, and then I relearned it with regards to Objective-C. So I'm going to teach you everything that I learned, and hopefully you'll have a very clear picture just in general polymorphism, not even specific to Objective-C, but just kind of what the programming community talks about when they talk about polymorphism. So how Objective-C for Dummies explained it is the ability of different objects to respond to the same message. So like that string in that picture, each one in its own way. So that was how Objective-C for Dummies said it. Now, programming in Objective-C, another book that I read, it said the capability to share the same method name across different classes. So that kind of goes a little bit more in depth about how you would achieve the statement up above. And then they also said enables programs to be developed so that objects from different classes can define methods that share the same name. Basically, just kind of rephrasing. So you create a set of classes with the same method names, but different implementation for each method. That's how you're able to achieve this state where you have different objects that respond differently. Because remember, everything is programmed. We are programming. So sometimes when you hear things like this explained, you think it just kind of like magically happens. But no, I mean, you're programming the different functionality in these methods. So it's when you send like the detail method, it is programmed to do something different. But on kind of a higher level, you can think about it where no, the object is just responds differently because it's something different. But remember that the code for that method is different. So really, basically, what it comes down to is just that you can have the same method name, but different implementation for each method. So that's kind of what it boils down to. But the way I've heard it with Objective-C explained is kind of, I liked it more than how I heard it with Java, because this is how I heard it explained from the Virginia Tech Computer Science Department when I was taking a software design class and we were learning Java. So they just described polymorphism with method overloading and method overriding. So now that I see it here, theirs was focusing on having different method names, or having the same method name and then different functionality. But just kind of the way they explained it, it didn't really click and sync with what they were saying. So this slide isn't very important. I'm just doing it kind of to be thorough, and I want to teach you guys as much as I know. And so if you hear these terms in other languages, you're not like, whoa, that isn't polymorphism. It is, but I don't know, it's just a little bit different way of thinking about it. So make sure you understand the last slide, and then this slide is just kind of for your own benefit. So anyways, the way they described it was, the first way was with method overloading. So you have the same name for the method, but they differ in their parameters. Remember, parameters are what you pass into a function. So when you call that function, you can pass in different objects, and then that object is used in that function. So it's not supported in Objective-C, but it's sort of there, but not really. So in Objective-C, those are two function names in Objective-C. The parameters are tied into the function name. So you can't just toss in more parameters. You need specific spots in the name. So write to file, and then you'd pass in a string for the parameter path, and then you would pass in a string for the parameter a string. So you could also have another function that says write file to path from string and string, and then you would have to pass in path a string, b string. You'd have to pass in different strings for all three of those parameters. However, these would be two completely different functions. So you could code it so you sort of have method overloading, but it isn't, because it's two separate functions. Whereas in Java, you can actually just pass in, you can just load up parameters. So you could pass in like 5 strings, or you could pass in 1 string, and it's the same method. You don't have to recode it or change the name of the method or anything like that. So that's where polymorphism is kind of powerful in Java. Personally, I really prefer the way Objective-C does it, where the name and the parameters, it's all just like one big huge sentence. It's what I'm pretty comfortable with. I really enjoy it, actually. Now, the other thing that polymorphism, when I learned it with regards to the language Java, they talked about was method overriding, and that's a different functionality of a method. So what that means is you can have this drive method, and you can actually override what the method does. So you can call the super, so you call the implementation, and this is actually getting into inheritance here. So if this doesn't quite make sense, it's fine, but inheritance ties in with polymorphism, so it's cool how it all connects together. But so we have this method drive. You'd call it on like a car or vehicle object. So you call drive, but let's say in a subclass, we're going to call the superclass, we're going to override what drive does. So we actually say drive, and then we actually call the superclass's implementation of drive. So that's why you say super drive. So calling the superclass's implementation of drive. So then we have what drive does, but then we can add on to it. So then we can do like an nslog drive under the speed limit. So it's pretty cool. You could also change the implementation completely of what drive does. You could just say drive on, you could just have the nslog drive, but don't do that sort of stuff, because that's a bad way of programming where you're changing implementation throughout the structure of the program. It's difficult to follow, and you can get a lot of bugs that way. But it is possible. So again, that is how I learned it. at school with regards to the language Java. But with Objective-C, it's more kind of objects can react to the same message, but in different ways. But remember that why they can do that is because objects can be called the same name. So each explanation, whether it was in the programming books or at school, they all had to do with names, but they just kind of taught it and presented it in a different way. And it was confusing for me. So hopefully this cleared it up and you kind of see the big picture and understand a little bit better. But I made up this little story, I guess you could say, and hopefully this will really kind of nail down what polymorphism, what it's like. So we're going to have some objects. So we create some objects here. The first one is a mom object. So it's my mom, and then me, another object, and then my sister. So anyways, my mom is going to send a message to both me and my sister. And that message is pizza for supper. Now, how would both of us, we're two different objects, so you could think of me as a string and then my sister as an image object. So we're two completely different objects, and we each can react in our own way. So I'm excited, and my sister is also excited. Just happens that we both respond excitedly when we get the message pizza for supper. Now, if my mom were to change or update the message that she sent me to say that there's mushroom pizza for supper, my response would actually change to ew, no thanks, because I am programmed that way. I'm programmed to not want mushroom pizza. My sister, however, she would still respond excited. So that's really how polymorphism works. Remember, my sister was programmed to like mushroom pizza. I was programmed to not like it. That's why we're responding in this different way. So with polymorphism, before polymorphism, before we kind of started using it, messages used to be just kind of like commands, like take out the trash, and you just told the object to do it and it just did it. But now with polymorphism, messages aren't just commands, they're more like statements, and whoever's receiving the statement will react accordingly. So we're having tacos for supper, you either smile or you frown. You're either happy or disappointed. So polymorphism makes your programs easier to extend since you don't have to change the message to add or modify functionality. Because each object has its own version of the method, you can simply modify the method instead of changing the message. So polymorphism allows you to have the code for different responses to a message spread out in the methods of different objects. So instead of having them in a single function with control statements to manage all the different possibilities. So instead of having like an if and switch, so like if this object is a cash object, do this. If this is a credit object, do this. Instead of having all sorts of that type of stuff, you can actually combine both inheritance and polymorphism, as you see in this slide. So we can have just one transaction object, and we can have a method like create transaction and track spending. So that's just common functionality. But then we can use inheritance to create subclasses, both cash and credit, and then we have their own methods. So we have spend and deposit on both sides. But each one will implement spend and deposit in their own unique way. So when you can just simply say spend, and the cash object will spend and it will do everything properly that it needs to do. But when you send that same message to a credit object, it spends in its own special way. So that's the beauty of this. You don't have to say, well, like if this is a cash object, then do this. If this is a credit object, do this. You just code up the class structure of your program in this way, and then it just freaking works. Like, it's pretty sweet. So as long as you understand this concept right here on this slide, and you understand kind of why it's powerful, and kind of you get it, like it clicks, you're good to go. Don't get too caught up in any of these. Like, you need to understand inheritance. You need to understand polymorphism. In, I guess, the next lesson will be coding, and then the lesson after that, you need to understand encapsulation. Like, these are important things to understand, but it's not like when you're programming, it just kind of becomes like a second nature. It clicks a lot more once you're actually doing it. Because when I'm programming an app, I'm not like, oh, I need to remember to use polymorphism. It's just something you just kind of do. It's hard to explain. I guess you could, I don't know if this is a good analogy, but it's like walking. You're not like, okay, take one step and now the other foot, now the other foot. Like, you just walk, but you understand like how you're walking, but it just becomes kind of second nature. That's, I guess you could say, sort of like what this stuff is. So don't get too caught up in kind of these big programming ideas. But make sure you definitely kind of understand the general picture. So just to kind of nail it down a little bit more, I'm going to show you guys a quick example in Xcode. You guys can code along if you want. I'm going to create a completely new project and do that. So anyways, let's go into Xcode real quick. Okay, so here we are on the desktop, and I'm going to create a new Xcode project, and I'm currently using Xcode 6 Beta 2. And so I'm just going to create a new project here, and make sure you go to OS X application command line tool, then next, and I'll just call it driving, I suppose, and I'm going to save it to the desktop and hit create. Now, I guess I'll drag it out like this. I'm going to, go into the main.m, and so hello world, I'll do hello YouTube, and then build and run. And so it succeeded and printed that out in the console. So good. I'm going to take out this auto release stuff. Okay, so here we go. It works. Now we're going to create a couple files real quickly. Going to do new file, or you can just do Command N. Cocoa Touch classes, and it's going to be a subclass of NSObject. And let's call this one car. And then let's call this other one motorcycle. Okie dokie. And so we have this car class and a motorcycle class. So anyways, going to create we're going to create a new method, void, let's call it drive. Nice simple name. And going to create that same method over here in the .h files of each. So we create this drive method. Now we're going to, you can see you have a little error because there's no method definition for drive, but we're going to fix that. So void drive, and then what should we say? I guess we do nslog plus or minus 5 miles. I don't know. So we have this custom nslog for car, and then for motorcycle, we're going to do void drive, and then we'll do an nslog, but then we'll put weave in between vehicles on the highway. Yeah, that's cool. So now if we go to our main file and we import car.h, and then we import motorcycle.h, so everything's good. And then in this main right here, we're going to create we're going to create a car object. So we can call car, and then we're going to call it I like the car Lotus, so yeah. And then I'm going to recall car, and then we call the new method, so that'll create a new car method. And then motorcycle, let's create a BMW motorcycle. Isn't programming fun? You can just create vehicles and motorcycles and cars and whatever. I mean, we could create a Ferrari if we wanted. So anyways, we get these methods, messages, warnings, because we're not using the variables, but we're about to fix that. So we're going to send Lotus the drive message. Going to send it there. Then we're going to call BMW. I'm going to say drive to you as well. And I can take that out. So anyways, let's go ahead and build and run. Quick little tip, if you do Command R, it builds and runs automatically. So anyways, bam, just like this, we call Lotus, we said drive. We said BMW drive. Go down here to the console, we have go the speed limit, plus or minus 5 miles. That's how Lotus responds to the drive message. We say BMW drive, weave in between vehicles on the highway. Bam. So that is polymorphism in action. Pretty powerful stuff. Hopefully you enjoyed that example and it made polymorphism click a little bit more. It's always good to see a programmatic example where you actually see it working and functioning in code. But anyways, let's go ahead and head into Xcode. We're going to be coding up a lot. We're going to be implementing inheritance and using polymorphism and restructuring the whole code basically. So that will be lesson 35 that we'll be going over. That'll just be a massive programming lesson. So that will be out very soon. Anyways, guys, thanks so much for watching. Like I said, I'll be finishing out these tutorials, taking you up through building an iOS and a Mac interface for this program. And then from there, I plan to do a Swift tutorial. So anyways, be sure to subscribe for the rest of the programming videos, the ObjectiveC tutorials, and then Swift tutorials after that. And then I also upload lots of different Mac and iOS videos as well. Anyways, guys, thanks so much for your support, and I'll see you in lesson 35 real soon. Later.